So for these last couple of questions in 5.3, we'll revisit those other formulas we saw on the first page. I'm going to go ahead and represent them with a's and b's again. We had the pattern of a squared plus 2ab plus b squared and a squared minus 2ab plus b squared. And those are forms that we know actually factor into the square of a binomial of either a plus b squared or a minus b squared. Now, as I mentioned before, these are not mandatory formulas or patterns or processes, because when you see something that fits one of these patterns, it is something that will fit the pattern of a either easy case number game or bottoms up approach. So like here, this 49z squared minus 14z plus 1, we could just forget these exist and just jump in it with the bottoms up approach. But we're going to look and see, because if we can get good at recognizing this pattern in a trinomial, it perhaps gets to the point where it's actually faster to just identify this factored form out of that trinomial. So we'll start with our first step, GCF, and the GCF is a 1, so that doesn't help. And so now we're looking at this form, and we're asking for, since there's a minus sign, we're looking for this one. We're asking, does this fit the pattern of a squared minus 2ab plus b? So similar to our difference of squares, we'll come off to the side here, and we'll ask that question. What would be a if we have a squared giving us 49z squared? Meaning if I square a and get 49, it's got to be a 7. And to square z, or square a and get z squared, I need to have a z. For b, the question of what would you square to get a 1 is just that, is 1. And so if we find a and b for the first and last term, think of it as almost like just a question of, well, what would that middle term then be? Negative 2 times a of 7z times b of 1 would be a negative 14z, which is what we've got. So that's kind of like the verifying that we have that pattern. And once you've verified you have the pattern, if you can recall this form or formula of a minus b squared, you can jump directly to that form, that binomial squared, as the factored form. All right, so on to the next one. We'll do a first step GCF. And with 1896 and 128, it might take you a little bit of time running through some factors, but we'll figure out that the GCF of those is a 2. And then as far as the variables, I got a cubed a squared a, so they all have an a in common. B squared b, no b, so no b's in common. And so that will be our GCF that we'll factor out, leaving us 9a squared plus 48 and just an ab plus 64 with just a b squared left over. So GCF factored out, and now we've got 3 terms. Same idea, we're going to ask the question. You certainly could jump into the bottoms-up approach. However, notice it'd be a 9 and a 64 that you'd be multiplying for that AC value. This is one place where if these numbers are large and it fits this very specific pattern, it might save you time, right? So if we're saying this is supposed to be the first pattern there, the squaring of the positive, since I see a plus, I'm going to go ahead and still use capital A's and B's. This is a squared, that's supposed to be plus 2ab, that's supposed to be b squared. Well, let's find a and b first. What would you square to get 9a squared? You'd square 3a. What would you square to get 64b squared? 8b. What would you get if you looked at 2 times a times b? 2 times 3a times 8b. 2 and 3 and 8, so that's 48 ab, which is exactly what we've got. So again, we verify that pattern with this a and b, so now we just say that we know that that trinomial will always factor to the a plus b quantity squared of 3a plus 8b quantity squared. And that's our factored form. And then lastly, one more here. We've got our x squared x no x form. Again, you could jump into the bottoms up, because if we tried a first step GCF, it does not help us. We're stuck with that 4. Or we can try this approach, noticing this looks like that comes from a square, and it looks like that comes from a square. So A would be 2x and B would be 3, right? 2x squared and 3 squared. And so, since we got a minus, we're saying this should be a minus 2ab term. Well, if we look at negative 2ab, that'll be a negative 2 times a 2x times a 3. And with that, we've got a negative 12x. Now, that doesn't give us that, right? That doesn't match that. So this pattern didn't work for us, right? And this is the risk you run when trying to see if these things match the pattern. Always start with A and B, because if you can't find an A or a B, then it's not going to work, right? You're not going to have it. But as far as this matching, this didn't match. So now we would say, well, that didn't work. So let's go back to that earlier method of bottoms up. So I'm looking at 4x squared minus 37x plus 9. Just going to write it again here. And so the bottoms up of 4 times 9 being 36. Looking at our various factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And for the bottoms up number game, numbers that multiply to a positive 36, add to a negative 37. Well, that turns out to be negative 1 and negative 36. So I'll pull them over here like we do. And then we use the A, the 4 in this case, as our denominator under each of those. Reduce if possible. That does not reduce. However, this one does completely down to a nice number. So there is our only bottom to bring up of 4x minus 1 and x minus 9 as our factors. So it did not factor with the squaring of the binomial method or formula or form, but it did in fact factor with bottoms up. So again, that brings me to the point of bottoms up will always factor it if it's factorable in this form. Otherwise, you're spending the time looking to see if it fits this very specific format with these values to see if it goes, if it factors as a squared of binomial. So it's not that it's bad, it's just sometimes it works, and lots of times it doesn't fit the trinomial you're working on, but that it wouldn't mean that it doesn't factor. It just means it doesn't factor as a square of a binomial.